Hello students, in this video we are going to now look at integer linear programming applications. So in integer linear programming, all or few variables will be taking only integer values like 3, 4, 5, etc. or or if it is a binary application, then they will take values only 0 and 1. So we'll look at these applications in subsequent videos also. But in this video, we are going to see there are applications like capital budgeting, fixed cost. These are the applications involving 0 1, which is typical called as binary variables. So capital budgeting, fixed cost, distribution system design, bank location, product design and market share optimization. So in this video we are going to look at bank location problem. So let us proceed to bank location problem. So in bank location, the case goes like this, that we have a long range planning department of Ohio Trust Companies. It's considering expanding its operation into 20 county region in northeastern Ohio. Currently, so this is the 20 county regions in northeastern Ohio. Currently, trust does not have a principal place of business, which is called as PPB, in any of the 20 counties. According to the banking laws in Ohio, if a bank establishes a principal place of business PPB in any county, branch banks can be established in that county and in adjacent county. However, to establish a new PPB, Ohio Trust must either obtain approval for a new bank from state superintendent of banks or purchase an existing bank. So in short, a PPB is required uh, in the particular county or in the adjacent counties so that we can do business in that county. For example, if you want to do a business in 10, then you can have a PPB in 10, or you can have PPGB in 9 or 8 or 11, etc. And to PPB is basically a bit costly and a lengthy what you call investment, because you need to either buy out a new existing branch, or you have to apply for that approval, and it is a basically a costly and a lengthy affair. So the overall objective is to minimize the required PPBs, and also you need to do business in all the counties. So this is how we this particular problem is set up, and we are going to use binary variable 0 1 for solving this problem. Now if you see, this is the table which shows which county has which adjacent counties, but you can also see them directly from the this particular arrangement here of counties. Now the to start with, what are our variables going to be? So as an initial stage or step in planning, Ohio Trust would like to determine the minimum number of PPBs necessary to do business throughout 20 county region. So a 0 1 integer programming model can be used to solve this location problem for Ohio Trust. So we define our variables like this, that our variable xi be equal to 1 if a PPB is established in that county, or 0, right? 0 means we are not establishing PPB in that county I, right? So this is a simple so we will have these 20 variables because we have 20 counties. So I will be from 1 to 20, and because we want to minimize the overall number of counties, we can put it mathematically that the total sum of the counties, the variables which are representing counties should be minimized. See, if you have PPB in every county, then all these variables x1 to x20 will become 1 and the total value will be 20. If you don't have any PPB, then the total value, all values for variables will be 0 and then the total will be 0. But then you can't do business in any of the county. So what is the minimum number required so that you do business in all the 20 counties? So that is why we need to minimize this equation x1 to x20 equal to x1 plus x2 plus up to x20, which we need to minimize. Now, if you want a branch in any, for example, if you want to do business here, so you can have a PPB. For example, if you want to do business in Istanbul, we want here. So a PPB can be here, or it can be here, or it can be here, or it can be here. So to do business in PPB in county 1, the PPB requirement is either 1 or 2 or 12 or 16, or even suppose there are PPBs in both also will do, BPBs in 4 also it will do, but that will be increasing our total cost. But we have another equation, that is our objective function will take care of minimization. Currently what we are trying to establish the constraint that to do a business in county 1, you can have x1 plus x2 plus x12 plus x16 should be equal to or greater than or equal to 1, because in any of this, if you have county, this will be greater than 1, 1 0 0 0 it will be greater than 1, or 1 1 0 0 2 it will be also greater than 1. So this is how we will establish equations for all the counties and for all the counties to do business like this. So the entire model will look like this. This is how you will quickly write the equations. So x1 plus x2 plus x12 plus x16 is greater than 1. For lake is this one, that is number 2. So for 2 it has to be x2 plus x3 plus x12 plus x1, right? All the addition should be greater than equal to 1, right? So this is how you will establish, the equations for all the counties. For example, for Carroll, that is the last county, Carroll, that is 20, you will see your equation will be x11 x19 plus x20 plus x14, 4 will be greater than equal to 1. So just cross checking, 11 14 19 20, so correct. So like this we will have 20 equations, and in that case you need to be very careful while writing the last constraint, which is your, normally it used to be our non-negative constraint where xi greater than equal to 0, but here we can't write that because our variable can be 0 also. So clearly we need to write this. This is a very important last row of the model, which clearly says that my all variables are binary. They can take value between 0 and 1, xi equal to 0 or 1, and I is from 1 to 20. So this is how we establish our model for solving the bank location problem. And if you look at the solution, when you use the solver, in solver what is to be done for this, I have explained it in another video of integer linear programming with Excel solver. So you can see that video to understand how to set up this kind of the model in solver. And when you solve this, you got here answer as x7 x11 and X12, X7, X11 and X12. So you want your PPBs to be in 7, 11 and 12. So going back into the this particular diagram, they are saying that we should have it either here 7, means we should have it in 7 and 11 and 12. So when you have these three PPBs, you can do business in all the 20 counties. So you can just cross check, because when you have it in 7, all this will get covered. When you have it in 11, all this part will get covered. And when you all have in 12, all this will get covered, right? So with this minimum 3 PPBs in 7, 11 and 12, the bank can do the business in all 20 counties, which was their objective. So this is how the bank location problem gets solved. Thank you.